Auto industry, one of the most carbon dioxide emitting sector, is now shifting towards electric vehicles to reduce carbon dioxide emissions. At the heart of an electric vehicle, there is a massive battery pack mainly composed of lithium-ion batteries providing power to the electric motor which further transmits its power on the wheels of the vehicle. Thus, like a conventional vehicle, there is no gasoline based engine producing power by burning the gasolines and in return emitting carbon dioxide into the air. So, from this, one can easily realize that an electric vehicle is more environmental friendly or environmentally greener than the conventional vehicles. But is it really so? Starting from the raw materials for the production of the lithium ion batteries for an electric vehicle to the disposal of the same from the same electric vehicle, the equations might have some different stories to tell. In this video, I will provide critical analysis of the overall environmental impact of the electric vehicles against conventional vehicles. So keep watching till the end. First of all, we have to know what's exactly meant to be an environmentally green product. Environmentally green refers to those products that we use that have minimal negative impact on the environment. That means the product must have the following characteristics. Number one, the product when in use must not produce harmful substances into air, water, or into the soil. Number two, the product must generate minimal waste upon end of its lifetime. In order to do so, the product must be recyclable. Number three, the product must not be the threat to the nature, that is to the biodiversity, to the water bodies, or to the natural habitats. Number four, the product to be used must be energy efficient. And number five, sustainability must be there of the product so that generations after generations may use it without the fear of crisis in the future. Thus, carbon dioxide emission is not the sole criteria to differentiate on environmental grounds the electric vehicles against conventional vehicles. These parameters are also there. For the production of the lithium-ion batteries, first lithium is extracted from its minerals. Chile, Bolivia, and Argentina are known as lithium triangle because they have the world's highest lithium deposits in the form of brine waters. First, brine water is pumped out beneath the Earth's surface and then transferred to the large open air reservoirs, such as in ponds, where it is evaporated by the heat of sunlight. This evaporation usually took 6 to 12 months to get concentrated lithium salts. Then the concentrated lithium salts is converted to the lithium carbonate by precipitation method. But in 2017, from a new finding, Australia overtook Chile in terms of the lithium deposits as a new lithium rich mineral named spodumene was discovered from Australia. Lithium carbonate is extracted from spodumene by crushing, pulverizing, heating, and finally treating with chemical reagents. This lithium carbonate is made to react with cobalt oxalate at 800 to 900 degrees Celsius to produce lithium cobalt oxide. A slurry of the lithium cobalt oxide was then coated on the aluminum sheet to manufacture the cathode of the lithium ion battery, whereas a slurry of the graphite was coated on the copper sheet to manufacture the anode of the lithium ion battery. The graphite is mainly produced from coal or from petrochemical products. Whereas for the conventional vehicles, the gasolines are produced by refining the crude oil extracting from the Earth's interior. Thus, after understanding the production process of the lithium-ion batteries and gasolines, we are in the position to critically analyze the environmental impact of these two vehicles in three stages based on those five parameters of environmental greenness. Here we will equalize the environmental impact of producing the bodies of the electric vehicle to that of the conventional vehicle by assuming the same environmental cost for their production. Stage 1 during the manufacturing of the lithium-ion batteries versus production of the gasolines. It is very obvious that the strength of the chemical bonds in the solid materials is comparatively greater than that in the liquids. Thus, the energy required to extract the minerals from the solid material is comparatively higher than that from the liquids. Hence, the electric consumption to extract the lithium from its minerals is higher than that to extract gasolines. From a 2021 study conducted by United Kingdom on road vehicles, it was found that 46% of the electric vehicles' carbon dioxide emissions come from the production process, while for the internal combustion engine vehicles, they only account for 26%. Thus, the rating will be like this. During the production process, waste generated is very minimum. So, the rating will be positive for both these cases. During the mining phases of both lithium and gasolines, natural water bodies are contaminated, natural habitats are threatened. Thus, threats to the nature will always be negative for both these cases. Also, the production of lithium and the gasolines will obviously depend on the availability of the resources in the future. Thus, on sustainability, they are also negative. Stage 2 will be cars driving on roads. During the running stage of an electric vehicle, it releases almost zero carbon dioxide as compared to high volume carbon dioxide emitted by the conventional vehicles by burning gasolines. Not only carbon dioxide, conventional vehicles also releases harmful chemical substances like nitrogen oxides or particulate matters, etc. But during charging of an EV, it requires electricity, which in most cases generated from the thermal power plant. Thus, conventional vehicles are energy efficient in this case. The other categories are not applicable in much, thus the ratings will be of this nature. Stage 3 or final stage during the car's end of life. The environmental impact is much higher for the end of life of an electric vehicle as compared to the conventional vehicle. This is because of the lithium-ion batteries in the electric vehicles. If not disposed well, it may contaminate landfills or it may contaminate water bodies by leaching hazardous metals like nickel, cobalt, manganese, lithium, etc. Besides that, these used lithium-ion batteries may explode spontaneously in air, increasing the risk of fire. There are typically two types of recovery methods associated with the lithium-ion batteries recycling: pyrometallurgy and hydrometallurgy. Pyrometallurgical methods involve using thermal treatment technique to induce chemical change in the waste, often resulting the formation of an alloy. On the other hand, hydrometallurgy takes the advantage of the chemical properties of the metals in the aqueous solution to isolate and recover marketable products. Both these processes are energy intensive. Thus, if the recyclability of a lithium-ion battery is possible, then yes, it is sustainable. If you watch my carbon dioxide conversion video, then you would realize that carbon dioxide produced by the gasolines can be converted to some other energy materials. But I must say, from carbon dioxide back to gasoline is not possible until now, thus not sustainable. Thus, the results of the environmental impacts of an electric vehicle against that of a conventional vehicle is on your screen. This analysis clearly depicts the true side of using an electric vehicle. But now you ask me, then why this shift from conventional vehicles to the electric vehicles is needed? Yes, it is needed because the resources of the fossil fuel is continuously depleting. And we must have an alternative option for our transportation sector. But if we think that an electric vehicle is less environmentally impacting than a conventional vehicle, then we might not be correct. If you have any queries to this topic, then please let me know in the comment box. I will be happy to answer you. If you like this video, then share this video as much as possible and we will meet in the next one.